Wednesday to everyone. My name is Jeff DeVerter, Chief Technology Evangelist for us here at Rackspace Technology. I want to welcome you to another episode of Cloud Talk Live. That's right, back for another one. We're here every week. Last week I did it from Vegas, which was super fun, and a great guest. And you're going to love what we get to talk about here today. But before we get into that, a lot of the usual housekeeping items I want to go over. And that starts with, of course, the fact that I'd love to know who is here with us today. So feel free to introduce yourselves in the comments, whatever platform you're on. So who are you and where are you? This is a global audience, so we want everyone to know in the community where everybody's coming in from. We've had them from, well, India's always here. Sydney was in last week. South Africa, South America. Everyone kind of shows up for these, which is super fun. Really do appreciate that. And also, of course, this program is part of our Solve program here at Rackspace, and that means it's our thought leadership program. So if you want to reach us, first thing you can do is just send us an email over at solve@rackspace.com. All right, we've got San Antonio showing up here today. Of course, Sean is here, rainy San Antonio. Sean, I'm out at the ranch, and we had our rain last night, so you get it now. And Kimberly, glad that you are here as well. Everybody, be like Sean and Kimberly and introduce yourselves. So again, this is all part, and Michael's here. Michael gets like the star. I think you and Sean are neck and neck for who has been here the most. So Bangalore, very nice. So as part of the Solve program, if you guys want to learn more, the podcast or articles or our research, you can just head over to rackspace.com/solve. And that's the thought leadership section of our webpage. But rest assured, as thought leadership, you will not be hounded for your email. You will not be hounded for what would you like to buy today. That's right. And so just I'd love for you to go check out some of the content that we have over there. Now, as always, this episode is intended to bring thought leaders in the market here to have a conversation, not just with me, but with you all. You guys are here, you're introducing yourselves, which is fantastic. Another person from Houston is here, Fernando. Glad you're here as well. I'm trying to keep up with all the names. Shahnar is here from probably far away. But with that, everyone, thank you so much for being here, for introducing yourselves. But with that, what I'd like to do now is introduce you to Sean Orrin, not Sean Gardner, to Steve Orrin. Steve is my guest today, and so we also have manning the controls in the back for the first time in a good long time, producer Megan. Producer Daniel is taking some much-needed time off. So Megan's back there running the shop. So Megan, let's bring Steve up onto stage, if you don't mind. So Steve, welcome to Cloud Talk Live. Your first time here.
Yes, it is. And thanks for having me today, Jeff.
So glad that you are. Now you're coming to us from Northern Virginia, correct?
That is correct. From just outside D.C.
Just outside D.C. One might think that you would work with the federal government in some fit or fashion, living in Northern Virginia.
That would be correct. I do. I'm the federal CTO for Intel Corporation and spend the majority of my time working with the federal government as well as with public sector, state and local governments across the U.S.
Pretty cool stuff. Now this is not a new role or new job working over at Intel. Looks like about 18 years you've spent there.
That is correct. I've been in Intel since 2005. My first stint was running security pathfinding, so innovation projects of security and cybersecurity use cases on top of hardware, and then took on the federal role about 9 years ago.
Very good. Now I had this question, I'm sure others do as well, but let's talk about when we think about federal government and Intel working with the federal government. When I think Intel, I think chips. So tell me how you're gluing, the business use cases and not just in and around silicon.
So it's a very good question, Jeff. And we are known for the chips, and that is what we build. And two things to know about those chips. Number one, the chips are everywhere. When we say Intel is inside, we mean it. From the edge all the way to the cloud, the network, and everything in between. But we're also responsible for and drive the sort of firmware and software that run on those chips. We are, at any given time, one of the top 10 largest software development companies in the world. We have over 19,000 software developers and architects.
That's incredible.
Driving software up that stack to make everything from Rackspace in the cloud to networking equipment and laptops run best on Intel. To that end, a lot of what we do is help the government adopt those technologies and meet their mission and enterprise needs with both hardware and software and architecture to help them drive what they're trying to do.
Steve, it's really easy for us, even me who works in technology every single day, to forget when we're talking about hardware manufacturers that hardware is as useful as the software that drives it. And then we think, oh, you mean the operating system? Nope, there is a big fat layer that sits between the operating system and those billions of transistors. So 19,000 software developers, that's incredible.
It is indeed. And one of the largest committers to open source, as well as to developing commercial software solutions and capabilities for the commercial market. So we play in a lot of different arenas, and we commit a lot of code to the open source. We maintain a lot of projects, because our goal is to really help enable the broader ecosystem. If it runs best on Intel, it helps the end customer. It helps our ecosystem deliver those chips to market.
That's really interesting. I love the fact that we're getting a little more understanding there. Now, let's talk about what makes, the need for somebody like yourself in a CTO type role to be focused on the federal government. So obviously, I guess that means that the federal government has unique requirements and standards and things that you have to make. But what makes the federal implementation of Intel, both hardware and software, unique or different?
So, Jeff, that's a really good question. And the way I like to look at it is it really is from two perspectives. Number one, we have to remember the federal government and public sector at large is a huge vertical market.
Yeah.
It operates very differently from, say, financial services, healthcare, or other verticals. Oftentimes the buys can come in large numbers or in many small numbers. But when you collect it all together, the federal market is one of the largest procurers of technology, and has one of the largest IT budgets in the world. The other interesting aspect of federal is it's a representation of every other market out there. When you think about sort of technology domains or vertical markets, financial services, healthcare, the federal government has it. You want to talk about large healthcare environments? The VA is the largest insurer and medical provider. CMS and IRS are some of the largest financial institutions, driving financial transactions, driving Medicaid and Medicare payments. And you look at sort of edge computing, smart cities kind of use case, so smart bases, smart ships, smart buildings.
You guys are leading the charge there.
Exactly. So what you find is almost every other vertical is represented in the government. So if you solve it for the government, it easily fairly easily transitions to commercial viability and commercial products as well.
Yeah, I guess rarely is the federal government going to have a requirement that the commercial market is going to need something more stringent or more secure or whatever it might be. If it, like you said, if it works for the federal government, the U.S. federal government, it's going to work for the rest of the market.
Exactly. And the nice thing about the federal government is they come with the scale. So if you're able to meet their complexity and scale needs, then you'll be able to solve it for the other scale providers, financial services, retail, manufacturing, and the others.
Steve, it's easy for us to think about the federal government as just, hey, this is a government institution, and as such, that's the singular vertical that it lives in. But what you just said a few seconds ago is really impactful in that it's also one of the largest healthcare verticals. It's also a financial vertical. It's also, smart cities and future tech type stuff. And I think that's an important distinction and complexity when thinking about dealing with the federal government.
That is correct. And the interplay between those agencies and how that comes together adds to some of that complexity. The acquisition cycles are different, but the representative, use cases and needs are very similar to what you find in those vertical markets. And oftentimes they use a lot of the same software and architectures. They're adopting cloud like every other market. They're doing edge to cloud use cases and enabling sensors. So you see a lot of those same use cases with more stringent security requirements often, or slightly different integration requirements. But a lot of I call it the 80-20 rule. 80% of a commercial solution will work for the federal government, and then they have their 20% uniqueness or special security requirements that they have today. But oftentimes you see they're the vanguard for some of those requirements that will start to show up in the commercial and private sectors a year or two later.
That's really interesting that it becomes this requirement, storehouse of things that then drive the commercial market. So Steve, before I bragged a little bit about the fact that this is a global audience, but I don't know if you've been watching the chat here, but we've of course have San Antonio here. India is here. Bangalore is here. Angola is here. Welcome, Amato. So glad that you're here. Uganda, Kovo, glad that you have joined as well. And El Salvador. I don't know if we've had El Salvador before. Maybe we have, but I'm so glad that you guys are all here. Thank you so much for joining. Well, Steve, when I think federal government and I think technology, I think federal government at large. Let's just take it to the larger thing. I think slow. I think bureaucracy. And I don't necessarily think about cutting edge outside of maybe some very specific military situations. And so when we were chatting before, you were talking about how even AI has been used for a long time, even in some non-sexy areas, which is, I think, is where AI has had a huge opportunity to kind of live in the shadows for a while. Why don't you talk a little bit about how the federal government is using some of these newer technologies to innovate and just to be better?
So, Jeff, you bring up a couple of really good points there, and we'll start with sort of that perception of the government as being slow or left in the dark ages, and I think that's much more a perception than reality. Now, granted, large organizations have bureaucracy, are not as quick moving and nimble as sort of startups or built on the web kind of environments. There's a lot of legacy there as well, and silos of excellence, as we like to call them. But at the same time, you have massive amounts of funding for innovation. They've got whole agencies like DARPA dedicated to driving the next generation of technology adoption across the government. So we see some of both. And honestly, if you go look at any other industry, you look at financial services, you find the same thing in pockets. Just because of the government's scale and it touches everyone's lives, we see it more often. But to your second point of where the government's been leading the charge on innovations, I want to give two examples. One, you mentioned about the non-sexy use case. Early on in the adoption and investigation to AI and machine learning and looking at ways to improve and get efficiencies into both the mission and enterprise, there was a project that was kicked off in the Air Force. And everyone thinks, oh, Air Force, they're doing advanced sensor detection or something interesting on logistics. They actually pointed that AI machine learning at their contract infrastructure, at their acquisitions and procurement, looking at trying to reduce the inefficiencies, the redundancy, a lot of the red tape that was there. They found a lot of overlap and sort of double, things that were sort of done once and then they did it again and again with it because they didn't have that insight into their contracts and into their procurement strategy and procurement acquisitions. And so they let loose an AI machine learning model to look at those and to be able to understand their contracts environment. And we're able to get amazing performance improvements, both in the reducing of cost inefficiencies, speeding up the process of doing acquisitions by being able to identify areas where they had overlap or areas where they've already covered. So they were able to focus in on the key things they needed to acquire. And they were able to, and they published the papers on this. You can actually go online and look them up of the efficiencies they were able to gain in both what they already had bought, but as well as driving their strategy going forward. And this is a great example of using AI to affect the bottom line. In the case of the Air Force, it was inefficiency in doing contracting, but it was something that was easy to do because it didn't scare anyone, if you think about it. A lot of times people worry about AI taking their job. And
we worry about it taking our jobs or taking over the world. Yeah, and it's interesting, and it's a use case that I talk about a lot, and that is that needle in the haystack use case. I mean, the federal government, massive organization. I can only imagine in the Air Force how many contracts that you're talking about when they said, hey, let's go look at all of them and look for the inefficiencies. We do similar things here at Rackspace. I mean, we have over 120,000 customers, and so you can only imagine the amount of technical, the tickets, the issues, the things that we watch for. Well, we use machine learning operations software that goes and looks at the details of all of those things, to look for the trends, to look for anything that can be automated out in the future. If we do the same thing to solve the same problem every time, maybe we could just do it automatically and not engage with a human.
Yeah, that's exactly a great use case of, getting out those, making the operations more efficient and also seeing the trends of what's going on so you can build better solutions for those trends.
That's great. That's great. Well, so I feel like AI is hidden in the wings since back in that 2017, 18, and AI goes back, it goes back decades. It's just recently that we've had enough data and enough computing power to actually do something with it. But it's hidden and done some really cool stuff in the background. Again, we talk about it from a governmental sort of thing. My brain goes to DoD. I think of advanced targeting systems and all sorts of things that go boom. But that's not all the places, of course, that's being used. Talk to me a little bit about the Forestry Service.
Yeah. So one example that was demonstrated was looking at forestry. And so, okay, forestry, part of the interior that manages our national forests. And today, the problem set was being able to get early detection of sort of disease in the forest, of blight in trees, or be able to do better mapping of the health of the trails and the health of the forest, of checking, and now in California, checking for forest fires requires a massive human effort. And again, that's just not efficient and you don't get the coverage. So there was a project where they looked to drones to be able to do coordinated semi-autonomous drones flying through the forest to be able to do those sort of detection of hotspots potential for like wildfires, look at the health, and do real-time object recognition to be able to detect the early stages of blight by being able to recognize what the characteristics of blight were on a tree using an AI algorithm. And they were able to not only do early detection and be able to catch blight much quicker so that it doesn't become catastrophic to a given forest area, but we're able to do it at scale. So instead of relying on a couple of forest rangers walking through the trails, they got a lot more coverage by having drones fly through the forest, auto-navigate through the brush and through the trees and the foliage, and be able to get back those real-time results of where they were detecting blight at scale. And so it was a really good example of using AI to benefit all of the citizens to have better health in our natural forests and to really augment what the forestry does today of maintaining the forestry health. And so a really powerful use case, nothing to do with the military, but really leveraging off commercial and federal use case technology development to drive these next generation use cases. In this case, for forestry, we see similar things in USDA and a lot of other of these sort of massive sensor kind of use cases where we're trying to automate early detection, whether it be a blight in the forest or potentially disease in livestock. These kind of use cases are what touches all of us, but we often don't see.
Yeah, and we think about blight as a specific example with those drones, and that's an incredible use case, and it scales the feet on the ground, if you will. It scales them to be able to then not just make decisions faster, but then to be able to act faster. One, to keep it stuff. What could they go in from prescribed cutting or burning to be able to stem that. But it also impacts, us humans as well. We think about forestry. Oh, it's people who play with animals and trees. But the management of that becomes incredibly important. You mentioned California earlier. That we all know they have wildfire issues, and being able to do prescribed work based on what they're observing in the state of those forests becomes really important in preventing damage or loss of life in humans.
Exactly. And there are actually several prototypes and projects in flight today across California and the Midwest that have put both mobile and fixed sensors in place to do those early detection, both of the state of the brush, if you will. So if there are potential places where it could happen, as well as built into that is the logistics to make sure you have the right supplies, the right people, so that when something does happen, you're able to respond much quicker. And again, is mapping of both what you're detecting in real time to actually the back end, which is, okay, how do I respond? Do I make sure I have enough water in the tanks of the various different firefighting? Do I have people on ready trained to deal with it? And so you have that logistics management part tied into the action. And that's really where we start to see those efficiencies come to bear.
Well, and here's what I get excited about as well, because when we were chatting before, we think about unleashing the AI, and the AI, everybody gets so scared about unleashing the AI. So we go and look for these benign areas where we can just scale humans in a good, positive way. Well, you talk about, the sensors. Now we're doing this proactively. We're talking about do we have water deployed into areas? We can now move sensors into those areas and start to manage and look at that. Now, I've got a little bit of work inside of the federal government. I worked for HP for a while, and we were working on what all can you say about it? But it was ultimately a database that would manage the health of the U.S., of the soldiers across all of them, just to be able to gauge a readiness, just think about gauging a readiness. And when we think about that can be applied very much into this area. How can we gauge readiness to make sure that should an issue occur in the forest, that we're going to be ready to do that? Because when we can take human eyes who can get blurry at times and put AI on top of that to flash a light when it's important, that really can help the situation.
Indeed.
Well, so Intel and the federal government, let's talk about some of the other areas that Intel is making an impact inside of the federal government in our last few minutes that we have here. What other interesting examples might you have for us?
Sure. So as we know, cloud is a big part of the federal government story. We have DISA put out the Joint Warfighter Cloud Computing Service, or JWCC, is the big cloud initiative. Every agency is driving cloud initiatives at scale. And it's really about how do you adopt cloud in the appropriate way. And we're seeing it's not just, well, let's dump everything into a public cloud. It's really about understanding the edge to cloud, or the hybrid multi-cloud architectures, to be able to affect the mission, because not everything should go to the cloud or to a public cloud, and not everything is easy to transfer from a data perspective. Sometimes you need the data to be relevant where it's generated. And so we're seeing this sort of edge to cloud architecture become a prevalent part of these contracts and a prevalent part of the strategy. And then overlaying that, then you start hearing, like the executive order around zero trust, and how do we apply security end to end in a zero trust way. This is where Intel is closely working with the government, both to give the operational performance and capabilities for the cloud, edge to cloud. If you have a common architecture, you build once, deploy everywhere, have a common software stack with one API and others to give you build it, you deploy it, and it can scale up and down the stack. And then integrated security from the hardware through the software ecosystem. We talked earlier about how Intel has software engineers that are helping the cloud and helping the operating system vendors. We are also a major contributor and work with a large variety of security ISVs to help their software not only run fast on Intel, but to get insights from the hardware so that they can see under the OS, so they can manage security at scale. And that ecosystem, along with the cloud, is really how we can help the government scale their security and cloud operations to meet these, large scale needs and opportunities.
Yeah, I love that you guys are opening up and giving some visibility underneath the operating system, those, whether it's exposed in APIs or just endpoints that can be connected to, because the bad guys are just getting badder, and there's more of them, and they're getting craftier and craftier. So the more visibility, and I love that that Intel, we think of just this, Intel inside, where's the chip, and is working with those software vendors in the security space to be able to give greater visibility into what's actually happening down at that silicon level.
Exactly, Jeff, and more to come there too, as we keep innovating together with the ecosystem.
Yeah. Well, you made another point, and I'm glad you brought it up, and that is, in this world that we live in, that is all cloud, cloud, cloud. We have a cloud-first model, and what the world's realizing is the cloud is an amazing tool that solves 1,000,001 problems. But not everything fits into there. You called a couple of examples out. The biggest in my mind is data. When you ship all that data to the cloud, and let's say that everything's going to live there, it's really hard and expensive to get it out of that environment. And you can't necessarily control exactly where and when it is. But when you build an architecture that is everybody is as an equal footing, and you're architecting for outcomes, not necessarily for endpoints, then it starts to get really interesting.
Exactly, Jeff. That's you said the key word there, architecting for outcomes.
Yeah, and that's what a lot of people lose sight of. And we're seeing more and more people who, over the past 4 or 5 years, who basically snow shoveled their entire data centers out into the cloud, are realizing that maybe not everything really belonged there. And the way that I tend to think about this is we got so excited about moving everything out to the cloud that we stopped thinking about what the desired outcome actually was. And here's what I think the world learned. And there were a couple of key moments we went through. First, there was the mid-teens, and everybody said, "Hey, move to the cloud. It'll be so much cheaper and so much better." Whatever. And then along comes COVID, and now we think data. We got to get the data in a common location so that all the people who now work from home have access to it. So off the data went. And then everybody looked at their bills, and they looked at their outcomes and their behaviors, and they weren't as satisfied. But there was one thing that I think most realized: running a data center is not anybody's core competency. And so that's where I see companies like ours and others that are like ours. You see Equinix really moving into this space. You see Digital Realty, who before had just been in the network transit space, now opening up their data centers to colo and other things like that. And I think that has to be a great environment for, as you talk about, the customer out to the data center, to the cloud, to the edge environments inside of Intel, has got to be a great market for what's happening at Intel.
It is, and understanding that it's having the right compute in the right location from the edge through the network to the cloud or in the private and public clouds so that you can move data when needed. And I think you see the government, I'll pick on JWC as a great example, architected from the get-go as a multi-cloud, where all 4 cloud providers had to be able to prove that they could interoperate, because the government did not want to get that same, they didn't want to be locked in. They understood that there'd be an edge to cloud use case and that data needed to be able to flow based on the needs of the services, of the outcomes, not just the needs of the cloud architecture. And so we're seeing that approach of a multi-cloud based strategy and then driving that into the ecosystem in order to be able to get what they need. And you're finding a variety of interesting solutions of both coming from both angles, from the cloud providers moving to more edge-based solutions, the edge and let's call them the private cloud providers like yourselves, building out those sort of hook points so that you can take advantage of the services you want from the cloud, but still maintain that locus of control and that locus of data management where you need it.
Well, Steve, here I thought everything was going to be so unique and different to the federal government, but what I hear you saying is exactly what I hear in enterprise. It's exactly what I hear in mid-market, and that is ultimately give me the right outcome, give me the right technology at the right time, in the right place. I used to just say the right technology at the right time. Now I say in the right place. And it'll drive the right business outcomes. Not technology for technology's sake. You and I get excited a bit in the morning about getting up and see what changed. But at the end of the day, it has to make sense for the business.
Exactly.
Steve, thank you so much for being on the program. I don't know how 30 minutes just blipped away, but it did. But I'm so glad you were on the program today. Love to have you back and continue the conversation. I'm sure you have 1,000,001 other examples you could give us about what the federal government is doing great with technology.
Thank you very much, Jeff. It was a pleasure to be here today and look forward to our next conversation.
Awesome. Thank you so much for being here. And everyone, thank you for sticking with the program here this morning. As always, we are here every Tuesday morning at 8:30 Central Time. And next week is no different. I've got a really interesting conversation coming up next week with a brand new racker who's helping in sales enablement and has actually written a really cool book about some of the ways to connect those communities and the technology that they're delivering. So hopefully we'll be able to make that. We've got a great guest and you're going to enjoy hearing from her. So until next week, everybody. Oh, fancy music. I look forward to seeing you next week. So please head over to rackspace.com/solve to get all the additional information that you may want to learn. And until next week, guys, I'll see you on LinkedIn next Tuesday on Cloud Talk Live.